Z-scores can be used to find probabilities. So we're going to reference this table, and it should be in your packet, where you see on one side we have Z-scores, and they all correspond to probabilities. Now, one thing to know about this is that these probabilities are always to the left. So what that means is if I draw a normal distribution curve and I have a z-score of, let's go with negative 1.2. Negative 1.2 is here. That means the area to the left is this, 0.1151. So the probability is always to the left of the z-score. And whenever I can, I'm going to draw a picture so that you can see what I'm talking about. All right. So what proportion of men are shorter than 63 inches? Okay, we are using the same information from the previous video where that the mean is 70 and the standard deviation is 5. So we first have to find a z-score. So ZE is value minus the mean divided by the standard deviation. Negative 7 divided by 5 is negative 1.4. Now, if I draw a picture, we know that the z-score of 0 is in the middle. So that means negative 1.4 is somewhere over here, and it doesn't have to be exact. But we're looking for men that are shorter. Shorter means less, less is to the left. So we're going to go to our table, find negative 1.4, which is here, and here's my proportion to the left. So 0.0808 or 8.08%. So if you're looking at men, 8%, roughly 8% of men would be shorter than 63 inches. Well, then that goes along, what proportion of men are taller than 63 inches? Well, taller would be on this side. And if the whole thing is all, like everything underneath here is 100%, and we know that 100% is equal to 1. So 1 minus 0.0808 will give me the area to the right, which is 0.9192. So on this side, we have 91.92%. Right? Makes sense, right? The z-score kind of splits the normal curve into two pieces. And to the left of it is 8%, to the right of it is roughly 92%. All right, let's talk about Danny DeVito. So Danny DeVito is 5 feet tall. What's the z-score for Danny's height? Again, he's a man, so the mean is 70, the standard deviation is 5. All right, so we find the z-score. Z equals, 5 feet, multiply that by 12, so he's 60 inches. Because remember, everything is in inches. So 60 minus 70 divided by 5, negative 10 divided by 5 is negative 2. That's the z-score. So that answers this question, but when we're looking at part B, I've got my normal curve. Ooh, that's a good one. I know that 0 is in the middle, negative 2 is somewhere over here. What proportion of the population of men are shorter? Well, shorter is to the left. So you go back to that table, the z-score table, you find negative 2, and it comes out to be 0.0228. So you could put that 0.0228, or 2.28% of men are shorter than Danny DeVito. Now using that, so we know that 0.0228 was our answer from part B, or 2.28%. How many men out of 100,000 would be expected to be as short or shorter than Danny DeVito? Now there's two different ways to do it. And if you think about this as 2.28%, you can do a proportion. 2.28% percents out of 100 would be X out of 100,000. We know how to solve proportions, right? We cross multiply, and we would get 2,280 men. The other way that you can do it is say, if I have a proportion of 0.0228, that's out of 1. If I multiply by 100,000, that will give me out of 100,000, which is 2280. Either way depends on how your brain works. What's the probability a man is taller than Danny DeVito? Well, go back to your normal curve piece here with 0 in the middle. We had negative 2, and over here was 0.0228. Taller than Danny DeVito is on the right. That's this side. So 1 minus 0.0228 gives us a 0.9772. That is the proportion of men that are taller than Danny DeVito, right? Almost 98% of men. All right, let's change gears and let's talk about the average height of a woman in the U.S. is 64 inches. So this is kind of a confusing question, so bear with me. What is the z-score for the average height of women when compared to men? So we're saying if we are still using the mean is 70, the standard deviation of 5. We're talking about men, the average man, the standard deviation. If we would throw in the average woman, where would she line up in terms of heights with men? Well, z-score. Value minus the mean over the standard deviation. Negative 6 over 5 is negative 1.2. There's your z-score. So in part B, we know that 0 is in the middle. Negative 1.2 would fall to the left. What is the probability a man is shorter? Shorter is to the left. So you go to the z-score table, you look up 1.2, and it gives you 0.1151. That is the probability a man is shorter than the average women. So 11.51% of men are shorter than the average woman. Now, we can use that same thing. So what proportion of men are taller? Well, if we have 0.1151 over here, then we'll take 1 minus 0.1151 to get the area on the right, which is taller, and that's 0.8849 or 88.49%. All right, a particular brand of tires lasts on average 40,000 miles. Okay, so the average is 40,000 with a standard deviation of 3,000. What is the probability a tire selected at random lasts more than 42,000? Okay, so our value is 42,000. You can't answer the probability question without a z-score. So z, value minus the mean is the standard deviation. Now when you do this, you get 2,000 over 3,000, which comes to be 0.67. Now 0.67 is not on the chart, so you need to round. And I always go closest to. 0.67 is closer to 0.65 than it is to 0.7. 0.65 is positive. Here's 0, so 0.65 would be over here. And the probability would be more, so now we're looking to the right. We're looking at this area over here. So when you go to your table and you look up 0.65, it gives you an answer of 0.7422, 7422, excuse me. And notice I wrote that to the left because the table always gives you to the left. To find the gray area on the right, to find this area over here, we will take 1 minus the 0.7422 to get our answer of 0.2578. 0.2578. And number 4, the average IQ score is 100 points with a standard deviation of 15. What is the probability of selecting someone at random with a score under 120? So we have a mean of 100, a standard deviation of 15, and a value of 120. So my z-score, 120 minus the mean, value minus mean divided by the standard deviation. 20 divided by 15 gives me a value of 1.33. Well, that is also not on the chart because we use a very abbreviated chart. So what's closest to that? 1.3. So when I make my graphic here, right, 0's in the middle, 1.3 is positive, it's going to be over here. And we want to know somebody less than that. So that's going to the left. Now I know just by looking that this has to be bigger than 50% because the red line splits it 50-50. So when I look at my table and I find 1.3 for a z-score, I end up with 90.32% because the table gave me 0.9032. So 90% of people have an IQ less than 120 points. That's what that means.